Today we're going to talk about piecewise functions. Piecewise functions are functions represented by a combination of equations. The rule for a piecewise function is different for different parts or pieces of the domain. For instance, in the example in your notes, movie ticket prices are often different for different age groups. So the function would assign a different ticket price for each domain or each age group. A special kind of piecewise function that is constant for each interval of its domain, such as the ticket price function, is called a step function. We're going to write a piecewise function for the admission prices given in the graph. Now, just like you always do, you're going to define the variables before you write the equation. So let's let P be the price of admission. Whoops. And that will be measured in dollars. X is going to be the age in years. So if you look at the graph, there are three different pieces of the graph. So when we write the equation, there will be three pieces. So P of X equals, and you're going to put a brace there because there are three equations. If you look at the first one, it says that the price of the admission tickets is $5 if the person is from 0 to 7 years of age. So you'll write 5 if, then you're going to write the domain. 0 is between, or X is between 0 and 7 years of age. Once you hit 7 years of age, the price jumps up. Once you hit 7, now it is $20. If 7 is less than or equal to X is less than or equal to 12. Now this is probably not a movie. It might be a theme park because it's $20. And I should not have put parentheses around that first one. Okay, once you hit 12 years of age, in most places you're considered an adult as far as admission prices. So then it will be $45 if X is greater than or equal to 12. And again, I messed up there. Hold on. Here we go. Sorry about that. And so it doesn't matter how old you are. If you're older than 12, you're going to pay $45 to get in. That's a simple example of a piecewise function. All right, we're going to skip the step function right now in your notes for 2 and 3. We will graph those again later. We're going to hop down to number 4, where we're going to evaluate a function. The first thing it asks you to do is evaluate the function f at -3. Because there are 2 equations, you have to figure out which one you're going to use. If you look at the domain, that's the part with the x's, find which of those domains makes -3 when you plug it in for x a true statement. In the first one, x minus 4, it says if x is less than -1. -3 is less than -1, so we will plug into the first equation. So x is -3 minus 4 gives you an answer of -7. When you're evaluating piecewise functions, you will only have one answer. You do not plug it in to multiple equations. Look at the next one, f of 4. If you plug in 4 for x, it makes the bottom equation's domain true. 4 is greater than or equal to -1. So for this one, we will plug into the bottom equation, replacing x with 4. And it gives us an answer of 11. Let's do the last one, f of -1. -1 makes the bottom domain true, so we will plug into the bottom equation. Make sure you plug into the original equation and then show your work. As always, answers only will not get you credit. All right, we're going to do number 5. We're going to work it the same way, except you have different equations. All right, it asks you to evaluate when x is -1. In this piecewise function, it makes the top equation true. So f of -1 would be 2 raised to the -1. And remember, a negative exponent flips the number. And so 2 to the -1 is 1/2. F of 3. 3 makes the bottom equation true. So we'll plug into the bottom equation. 5 times 3 gives you 15. Just remember, you can only have one answer when you're evaluating piecewise functions. The other examples we're going to do today are numbers 6 and 7, graphing equations on your notes. Let me write these down real quick. So if you have 2 equations, then you're going to have 2 pieces of your graph. When you're graphing these on your paper, make sure you copy down the original problem. If you have graph paper, you won't have to draw these little grids. But if you're drawing your own grids, please use a ruler. Okay, I want you to look at the top equation. And right here, oops, sorry about that. I'm looking for the highlighter. All right, so you're going to look at that equation. If you were going to graph that equation, it would be a line with a slope of -1 and a y-intercept of 2. So if you were going to graph that, you would have a point right there at 2, and then our slope would go down. Over. Okay, that's what our graph would look like. However, because of this domain, you're only going to draw that line for x's that are less than or equal to 0. So if you plug in 0 into here, you get 2. So this is going to be the end point of our line right here. Sorry. This is going to be the end point of your line. And it's going to be an open circle because it does not have an equal sign right here. Okay, so you're going to use your ruler and you're going to draw the line for all of the x's that are less than 0. And that's the first part of the equation. Okay, now we're going to look at the second part of the equation. That would be this one. Okay, it has a y-intercept of 1 and a slope of 2. So it would look like here, and it's got an equal sign, so this would be a closed circle, and we want all x's greater than or equal to 1. So we would want the ones that go this way. And so you would only draw that line for these x's. Now, anything else on your graph does not belong there. So be sure to erase any extra points you put and only have the points that represent the graph. Okay, notice that they don't intersect. Sometimes they do, sometimes they don't. Let's look at number 7. You would copy the problem on your own paper. If this were a homework problem. Make sure you include the domain. Sorry about that. Okay. So you're going to draw your grid. Now, I think it's easiest if you plug in this domain value here. That will give you the endpoint of that line. So if we plug in x equals 1, we get 1/2 times 1 plus 3/2 is 2. So this point up here would be at 1, 2. And it would be an open circle. Because there's no equal sign there. And then we want all of the x's that are less than 1. So that means it's going to go to the left. So the y-intercept is 3/2. You can also plug in any other point to get these lines, but it also goes through -3, 0. So this would look, if I could hit that point, this would look like that. Okay. We're going to do the bottom one. It is a line with slope of -1 and y-intercept of 3. So it would go through this point up here. It would go through that point. But we're going to plug in 1 to see where it starts. If we plug in 1 into this equation, we get -1 plus 3, which is 2. Oh, look, it fills in the circle there. So where it was an open circle, now that point gets filled in because of the second equation. And then from there, we're going to go down 1 over 1, down 1 over 1. Or you can plug in points. If we plug in 3 for x, we get 0. And so this equation, this line would look like that. So sometimes they're separated, as in number 6, and sometimes they are connected, as in number 7. Now, I didn't show you this on the other one, but I want you to label where the points intersect. And so on the other one, we had a transition point here, 0, 2, and at this one, 0, 1. So you're only going to label the transition points on a piecewise graph.